Kia ora and welcome to setting up mobile automation framework right from scratch, step number 4, and this is the most exciting part. We will do some coding, but before jumping into automating pages or components of our mobile application, we need to set up our framework. Before we get into it, we need some prerequisites, and for this step we will need IntelliJ. What are we covering during this step? We need to create our boilerplate or our initial framework using Spring Boot Initializer. We will design our project structure and creating folders to organize our code and files. We need to add the required dependency, and we're going to talk about it once we get to step. We need to configure something called dependency injection, and for that we will be using Pico container. We will add our first set of hook, and if you're familiar with automation testing in general, you will see that hook is normally what you add your before and after a scenario. And finally, we will create our test runner class. This will enable us to run tests through command line prompt. Right, let's start with a Spring Boot Initializer. For that, you need to go to start.io, and in this section we will be setting the parameters of our automation framework. We would like to set up a Maven project. This is how we will be managing our dependencies and packaging. The programming language of use is going to be Java, so we leave that as default. This section doesn't really matter because the only purpose of setting up this or using this website is to get the initial project set up, but we will not be using any of the Spring for this project. Next is your project metadata information, example group, and for practices just can do TechDojo or artifact. It's going to be mobile information. Project description is a mobile information sample. Group package is going to be jar, and then the Java version we want to use is going to be Java 21. Group. All our parameters are set, and the only thing left is just click on this button here that is called generate. What this will do is we'll download the initial project on a package, on a zip file. Right, now that we have downloaded our project, it's time for us to make use of IntelliJ and open the project so we can start organizing our folder structure so that we can accommodate for mobile automation, and we can identify our files and classes in a more efficient way. Now, the only thing that you need to do is just click on open, and then you need to navigate to the folder that you have downloaded. In this case, our folder is called mobile automation, and then click on open. Select on trust this project if you are presented with this window. Now it will prompt so many tips, so in my case I'm just going to close them, but feel free to go through them if you find some value on them. Now, the first thing we need to do is clean up our project, because as you know, this is a Spring Boot project. Now let's get rid of some of the class that came by default. One of them is this mobile automation application class. We don't need it anymore, so let's delete. Then let's delete the test class as well, and we need to go to the POM file, and here is where all our Maven libraries are located. Now we need to get rid of anything that makes reference to Spring Boot framework. So let's get rid of dependencies. We just leave the tags dependencies in plural, and we also need to get rid of this plugin as well. Otherwise, it may throw an exception or an error later. All right. So that's cleaning up our project, and now we can start creating a folder structure so we can visualize and organize our folders in a more efficient way. All right, let's start with the main folder, or Java main folder, which is this folder here. And as you can see, we have a package that is called techdojo.org.mobile automation. Now, under this package, I need you to create a series of packages as follows. We'll need to create a new Java package. The way you create it is right click Java package, and yes, it's going to live under mobile automation package. And the first package we will create is something called controller. Don't worry, this will make sense later. Second package we will be creating is, let's get rid of controller, and we follow the same process for the rest one. Custom package DTO. Now, DTO stands for data transfer objects, and basically in this package what we will be doing is allocating anything that relates with data or data structures. So this is how we make sure that data travels across different layers of our framework. Again, if this doesn't make sense to you now, don't worry, it will make sense later once we start implementing. Of course, we're going to have some helper classes. Then we have pages, because as we said at the beginning of this tutorial, we are going to follow page object model to structure our automation framework. And voila, that's the project structure for the Java main folder. Now we need to move to test folder, and in this one we need to create another sub package called step, and we also need to add a resource folder. For this one, you need to click right on there or on the test folder, right click, new, and we're going to call this one directory resource. Just select resources and then end. Now under resources, we need to create one more file, which is meta info/services, and don't worry, this will make sense in a bit. All right, cool. And we also need to add another folder to store or host our feature files. We will call this folder feature. There you go. So this is our project structure in a nutshell. All right, now that we have created a project structure, it's time for us to add some of those dependencies. Feel free to copy and paste. One good practice is always add your dependencies versions in the property or properties section of the POM file. And this is this one here. So at the time of this tutorial, the latest versions of Cucumber and Jackson is 7 and 2. Don't worry, this will be provided in the comment sections as well, so you have some idea on how to work with it. It is also good practice to have proper formatting, in case copy pasting didn't work out as expected, but we can fix it. Right, that's it. We have added our dependencies. Once dependencies are in the POM file, they will not get loaded by default. You need to click on this icon here, which is load any Maven change. And now what will happen in the background, all the dependencies that you just added will start downloading. Another cool way of refreshing these dependencies is clicking these two buttons. So this one will reload all Maven projects, and here will update or regenerate any independent the target folder will compile the entire code. Now you can see here there are some externals library, and you can observe that Cucumber is already part of this external. Right, this is updating our Maven repository. Just to give a quick summary of what we've done so far, a good practice is always add your dependencies, the version dependencies, part of the properties section of your POM file. And then the list of dependencies we added for this particular project is Cucumber, because we will be working with Cucumber. Then there is something called Pico Container, that's a dependency injection framework we will be using for this particular project. We are specifying that this Cucumber is particularly for Java. The scope is interesting. So scope means this will only be used on any packages that lives under the test folder. We will need some dependencies from Java 8 on formatting, and finally Jackson. That will allow us to work with a JSON file. And there you go. That's our Maven dependency for this project. Don't worry, I will share that with you. Alright, now that we have our project structure and we have a list of dependencies in place, the next step is for us to set up our dependency injection framework. Now, I want to be very clear. There are multiple dependency injection frameworks in the market that you can use. For example, you have a Spring Boot, which is quite common, and that's something that we could have used when setting up this project. But I find working with Pico Container quite flexible and comfortable. It's something that I have experience with. We can explore other frameworks later on, other dependency frameworks, but I recommend working with Pico Container because that's native to Cucumber. Alright, first step, we need to create a new class, and this is where the exciting part starts coming in. We need to write some code. We need to create a new Java class, and we're going to name this Java class Custom Pico Factory. Cool. Now, this class will implement Object Factory. This Object Factory comes from io.cucumber.core backend. Okay. Now it's complaining, it's saying, hey, you are implementing an interface, but you haven't implemented the abstract methods yet. So let's do that. Let's implement some of these methods. Cool. Now, by itself, this class will do absolutely anything, right? Because we still haven't done the implementation of these methods. These are just empty methods. In order for this to take effect, we need to create something called delegate, or a delegate object, which is nothing but a part of the Pico factory, a Pico factory instance. So let's do that. Private Pico factory, and then delegate. This will be equal to new Pico factory. Cool. Now, the implementation of these methods is very simple. We just need to make use of that delegate object dot start, and as you can see, we're just actually matching the name of the method that has been overridden with the name of the method of the delegate. That's it. Simple as that. This dot delegate dot stop. Now this will return false. Of course, we want to call some method, so let's do that. This dot delegate dot add class, and then the only thing we need to do is just pass this parameter here. Same for the get instance as well. This dot cool. Now, what dependency injection does is, instead of us creating a new object everywhere and creating tightly coupled components, we can centralize the creation of these objects in one single place, and that's going to be through our custom Pico. And we have a pool of objects which we can then get an instance from. What this enables us is to have a less tightly coupled application, and therefore is a more maintainable and more robust and more future-proof. So that's the main reason why we are using a dependency injection framework. Cool. So this is the first step. We need to create a custom Pico factory. We are implementing from the object factory, and we are implementing all these methods using the delegate, which is an instance of the next step is going back to the meta inf.services class, and under this folder, and under this folder we need to create a new file with the following name: io.cucumber.core.backend.objectfactory, and this is just a plain file, don't worry much about it. And under this file, what we're gonna do is we're just gonna call our custom Pico factory, so at least we're gonna make reference. And as you can see, as soon as you start typing the name of the package, which is TechDojo, it identified the custom Pico factory class. And last but not least, change, we need to add a property, or in this case a Cucumber property file. Let's do that now. And by the way you create files in IntelliJ is easy. Right click, new file, and we are adding the extension .properties. It automatically understands that this is a settings or configuration file. Now under this file we need to add the following property: Cucumber, and this will be making reference to techdojo.org.moral.automation or custom Pico factory again. Cool. And there you go. That's a setting up of our dependency injection framework with a Pico factory. Now, next is to create hooks. And as I said at the beginning of this session, hooks are are some of the elements or functions you call before and after each method. But in this case, there is something called object mapper. An object mapper becomes really helpful when we are creating tables on our feature file, and we are transforming these tables into objects. So our first hook is going to be that. It's going to be an object mapper, which will transform whatever object we put on the feature file as a table, and it will translate that into a Java object, something that we can understand and work better. Cool. So let's get on it. Hooks normally lives under steps, so we're going to go test Java, then steps, which is this package here. We're going to create a new hooks class, and we're going to implement. Now this implementation is just to tell that we are using dependency injection to access some of the classes. It will become very relevant soon, don't worry. For now, I just need you to copy and paste the following line of code. This comes from Jackson, if I'm not wrong, should be right. Let's give a little bit of formatting. Let's add some of these dependencies as well, so it's easy to do that. There you go, perfect. So now what I've done so far is just copy paste the code and make sure I have the right dependencies or imports on my Java class. Don't worry, I will explain more in detail what this class actually does once we go to the next part of the tutorial. But just in summary, this is nothing but a hook, and a hook can be things that we want the framework to do or action before and after, either tests or scenarios. But in this case, the type of hook we're doing is a transformation hook, which is taking an object from the feature file and is doing a transformation into a Java object. Now, last step is to create a test runner class. And just to do a quick recap of what we've done so far. So what we did at the beginning was to set up a project right from scratch using a Spring Boot initializer. Then we create a folder structure for our project. The third step was to add the required dependencies in our POM file, and for that you need to remember you want to use the properties section to capture to have the versioning of your dependencies in place. This will allow you to do a better dependency management in the future. If you want to upgrade your dependencies, you just do it on the proper section of the POM file. Step number 4 was to add dependency injection in our repository, and then we add some hooks into it, which is the step that we're currently on. Now, before we wrap up the setting up of our framework and we jump into doing some testing or creating some tests, automated tests with a Cucumber, we need to have something called test runner. And now this test runner will live in the base of the mobile automation framework. So we need to create a new Java class, and this Java class will be called test runner or UI mobile test. Let's move it to this. We need to move this file physically outside the package because we don't want it to be as part of our steps. So for that, you can use rebuild in things open in Finder. There you go. So we want to move the test runner away from, there you go. Let's go back, and that should be here now. Perfect. So we just move the test runner file outside the steps. Now the only thing we need to do here is just tell that we want to run Cucumber test. We import the necessary classes for that. Again, you don't need to do much, you just need to copy paste, follow the tutorial step by step, and until you get it working. And remember, if you face any challenges at any point, please feel free to drop a comment in the comment section, and I'm happy to get in touch with you and solve this problem together. Cool. So now what we're doing here is we have some Cucumber options. We are telling that the features lives in the class path features. These class path features get generated once the entire project is compiled, and normally this it creates a folder called target. This is the target folder. Then there is a plugin Pretty, which will create a XML report that we can and we can also generate some the results in a JSON format. The reason why we do that is because if we want to have if we want to have a CI/CD pipeline, we like to feed the CI/CD pipeline with this Cucumber JSON report. There you go. These are the different steps we follow in order to actually set up our framework from scratch. We are ready to start doing some coding, and the next step is for us to create our first feature file, our first step definition, and then run our test. See you next time. Now, in summary, We learned how to create a new Java project using Spring.io, and for that you can go to the website start.spring.io. We learned how to design our project structure before we actually start coding. This is very important for us to understand how we are going to organize our files, and this will help us to better maintain our code in the long term. We also learned how to manage Java or Maven dependencies, and we also learned how to use properties to manage dependencies versions. We configured dependency injection. In our case was Pico container or Pico factory. We add our first hook, and that was a transformer or a mapper. And then we create our first and only test runner class. Now the test runner class will enable us to run or execute tests through the command line prompt. Thank you guys. See you in the next step. We will set up our own or a first test following Cucumber and BDD scenarios. Bye.